Good evening to all of you. I welcome to this tutorial session on smart grid basics to advanced technologies. I hope my voice is audible to you. If it is not, then you can send a message. Okay. Otherwise, I will move on towards the lecture.
Yes, sir. Audible, sir.
Okay. So now in this session, what before I introduce in this session, what we will be going to do here is to recap the last week's lectures in a 2 hour session. Then I will solve some problems related to that session, and then we will conclude the session. So before I start the session, I would like to introduce myself. I am Mohd Owais, the Prime Minister Research Fellow in the Department of Electrical Engineering, Aligarh Muslim University. This is the tutorial session 10th. So, so now we will move on towards the lecture. Okay. So the first thing here in this, we have in the previous lectures, we have talked about the renewable integration, why it is necessary, and we have discussed in detail the two major, renewable sources of energy, which are solar and wind. In these, we have talked about that solar is generally a DC output. So if we want to use in our microgrid, then we have to use inverters for that. But wind generally gives output in the AC. Why? Because we convert this wind energy using the DFIG, doubly fed induction generators. So these sources can directly connect it to AC bus, but the solar-based sources can also connect it to AC or DC bus depending upon the usage of inverter or not. I have talked about in previous lectures regarding the microgrid. What is a microgrid? It is a small electrical system in which there are renewable energy sources, there are household loads, And in modern system, we can also say there are electric vehicle load also. Okay, so in a microgrid, generally renewable energy sources are there, loads are there, EV load also there in a modern system. And this microgrid, there will be many microgrid like this over a network, and they are interconnected and connected to the grid. So basically, there are two modes of operation of the grid. One is the grid on, or we can say grid connected. Other one is the islanded operation. Islanded operation. In islanded operation, what happens either due to intentionally or unintentionally, the microgrid, what happened? It gets disconnected from the grid. Okay, from PCC, which is point of common coupling. Okay, in the grid connected, or we can say grid on mode, the grid is connected to the microgrid and the energy supplied from there also. But in islanded mode of operation, the energy is generally supplied from the renewable energy sources which is inside the microgrid, because we already know that grid is disconnected from that microgrid. There are various problems in the microgrid, because whenever the supply gets disconnected due to inertia or various other problems, various other things, the operating parameters of the microgrid get disturbed, like there will be voltage instability, frequency will vary. So for these, there are various, I have talked about various controls techniques, how we can control the voltage and stability, how we can smoothen our frequency. So in that sense, we are going to study how the microgrid we can model, so that why the microgrid modeling is necessary, so that we can test the practical scenarios or situations which may happen in real world. Okay, so that's why we do the simulation or microgrid modeling and simulation and case study of various type of microgrid. Okay, so that whenever we apply those techniques on the real world situation, there should not be any, you know uh, there should not be any, like any untoward situation may get developed. Okay, so that's why if you want to have a smooth, or we can say a stable system, so therefore some lab testing, or we can say the modeling or simulation work should be done. So therefore, the modeling of the microgrid is very much important. What it does, the detailed modeling of a microgrid and its simulation helps helps in conduction of rigorous analysis, which I have just talked about. कि हम किस तरीके की एनालिसिस करते हैं, जिससे हमें कोई भी सिनारियो अगर रियल वर्ल्ड में सिचुएशन में आए, तो हम उसको पहले से ही कैलकुलेट करके बैठे, हमें पता होना चाहिए, वी शुड नो व्हाट एक्शंस और करेक्टिव एक्शन वी आर गोइंग टू अप्लाई. और इससे क्या कहता है, इट हेल्प्स इन identification of various challenges. Okay, and it also helps in giving feasible solution before any physical implementation. ओके, तो इसी वजह से जो माइक्रोग्रिड की मॉडलिंग है इट इज वेरी मच इम्पोर्टेंट. How close we can model our microgrid to a real world situation, real microgrid, it will help in giving a more feasible, or I can say more practical solution. Okay, so what it will help us? It will help us in in cost also. Let's say I will give you an example. Let's say we implement any any physical implementation before any testing. We don't test any, the all those things and just directly implemented it in the real world situation. So it will create another set of problem which we do not know beforehand. So that's why for before the physical implementation, the modeling and simulation work should be done. Okay. Now there are various simulators in the there are various simulators like RTDS. Okay, what does RTDS stand for? It is real time dynamic, sorry, real time digital simulator. Okay, so it will help in simulation of a microgrid. अब क्या होता है जो भी microgrid simulate किया जाएगा, it should be done on a software or like any on any software which is which is simulate all the characteristic of that. So RTDS क्या करता है? It provides a suitable platform for the detailed analysis of transients in time domain based. Okay, ठीक है. तो RTDS का क्या काम होता है? RTDS क्या होते हैं? These are simulators which gives a suitable platform so that we can model our microgrid and do a detailed analysis of different transients or various like that. और इन सब RTDS को क्या कहते हैं? These are known as EMT. What is EMT? Electromagnetic tra- transient simulator. ओके. अब क्या होता है कि सिमुलेशन जो है डिफरेंट टाइप्स का होता है. ठीक. लाइक इट इज broadly classified in two types. First is continuous, then other is it is hardware in loop based testing. ठीक है, which is also known as HIL test. This continuous is continuous real time simulation. Okay, so there is advantages of both. ओके, इसका क्या एडवांटेज होता है कंटिन्यूअस रियल टाइम सिमुलेशन का? इट विल मिमिक द रियल माइक्रोग्रिड, बिकॉज माइक्रोग्रिड, एक रियल माइक्रोग्रिड किस तरीके से काम करता है उसको मिमिक करना, उसको बिल्कुल सेम पैटर्न पे एक प्लेटफॉर्म बनाना, इट इज अ वेरी वेरी डिफिकल्ट टास्क। ओके, क्योंकि रियल वर्ल्ड में देयर आर डिफरेंट टाइप्स ऑफ अनसर्टेनिटी, तो उसको हम सिमुलेशन में कैरी जितने अच्छे तरीके से इम्प्लीमेंट कर लेंगे, द मोर रोबस्ट आवर आवर एल्गोरिथम और आवर कंट्रोल टेक्निक विल बी। ठीक है, तो उसके लिए अगर हम कंटिन्यूअस रियल टाइम सिमुलेशन यूज करते हैं, इट इज अ मच बेटर, बिकॉज इट simulates the system in terms of a real microgrid simulator. Like that, I will write it down here. It simulates the system such that it mimic the real microgrid network. ओके, जिस तरीके से एक माइक्रोग्रिड नेटवर्क बिहेव करता है, कंटिन्यूअस रियल टाइम सिमुलेशन अगर हम यूज करते हैं फॉर माइक्रोग्रिड एप्लीकेशन एंड सिमुलेशन मॉडलिंग, इट विल हेल्प इन दैट। Whereas on the other side, HIL, what it is? Hardware in loop testing। ठीक, तो अब ये क्या होता है? What it does here? It has the capability, it has the capability of real time simulators to permit the design and operation of any microgrid control, okay, of any microgrid control or or actually protection scheme, any protection scheme to be analyzed analyzed before they are implemented in the system। तो HIL क्या करता है? कोई भी हमने टेक्निक बनाई, ठीक है, हमने जस्ट से कि फॉर एनीथिंग वी डेवलप अ टेक्निक फॉर एनी माइक्रोग्रिड। अब उस टेक्निक को हम इसको टेस्ट करना चाहते हैं कि इज इट रियलिस्टिक और इट इज रिलायबल और इट इज डूइंग द वर्क which we are trying to achieve, is it not? So hardware in loop will give that platform for that technique, so that the aim which you are going to operate, or we could say the design and operation of any microgrid control which you are trying to achieve can be implemented on that HIL before actual implementation. Okay, so this is all about the microgrid modeling. So now we will see a microgrid, okay, a AC microgrid study. Here what it is, there is a three-phase 480 volt grid. This is supply. As you can see here, it is connected to the microgrid. So we can say this is a grid connected microgrid because the grid is connected to this. So supply has some reactance, admittance, or this is represented by this. And then comes a bus, which is known as a point of common coupling. So this point of common coupling will decide whether the microgrid is in islanded mode or a grid connected. If it is on, if it is off, it will decide this. So now after this, this is an AC bus because we are considering an AC microgrid. There are various types of load and renewable energy in this microgrid, which constitute the system architecture. Zero point 0.4 megawatt solar PV is here. Now, in order to connect to the AC bus, the inverter's operation has to be performed and then it is connected through a circuit breaker. There is an AC load of zero point 0.5 megawatt. It is also connected to circuit breaker. Why? Because if we want to any faulty isolate any faulty section, we can do with the help of these circuit breaker. And after the fault is removed or malfunction from that part of the network is removed, we can connect it again to the AC bus. Then there come the diesel generators, which is of 1.25 MVA. Then there is a lithium ion battery, which is a battery energy storage. To connect it to the AC bus, we are using an inverter, and after that it is connected through a. So this is a AC microgrid case study. Okay, so aim, the operation of this microgrid, there will be different types of modes of operation, which I have just told you about. One is grid connected mode. Okay, इसमें क्या होगा, majority of the power, ठीक है, और we say almost majority of the energy, or we can say power requirement, is supplied by grid. Okay, और इसमें क्या होता है, PV always operate in MPPT mode. MPPT क्या होता है, मैंने लास्ट टाइम में बताया था, आई विल रिवाइज इट, कि इसमें जो है where there is a maximum power happens. Okay, just a second. Okay, at that point is known as the MPPT point. Okay, अब इस मोड ऑफ ऑपरेशन में बैटरी either charges or discharges based upon the reference command. Okay, कि अगर SOC इतनी ज़्यादा है कि it can discharge, so it will discharge its energy. But based on अब इसकी SOC it is below, is it or if the SOC is near the the lower limit, then it will charge the battery. और डीजी मतलब सॉरी डीजल जनरेटर का क्या इसमें रोल रहता है, इट हेल्प इन वोल्टेज रेगुलेशन, वो कैसे, बाय कंट्रोलिंग दिट्स एक्साइटेशन. ठीक, तो ये फिर देयरफॉर नाउ another mode of operation is the isolated mode, or we can say an islanded mode of operation. इसमें क्या होता है, you already know कि grid is not connect. ठीक, अब इसमें पीवी क्या होता है, मे और मे नॉट, जनरली मे और मे नॉट बी ऑपरेटेड इन एमपीपीटी मोड. ठीक है, मैक्सिमम पावर. ठीक, अब इसमें जो है जनरली डीजल जनरेटर पिछले वाले में कैसे काम कर रहा था, इट इज वर्किंग एज अ वोल्टेज रेगुलेशन बाय कंट्रोलिंग इट्स the excitation, but here DG is operated in an isochronous mode and it gives voltage support and the frequency support. Why frequency support now? Because the grid is not connected over here. So the diesel generator has to provide the frequency support also. So in the islanded microgrid, क्योंकि हमारी फ्रीक्वेंसी एक ऑपरेटिंग लिमिट से नीचे नहीं जानी चाहिए. अब इसमें जो है देयर आर वेरियस इन्वर्टर कंट्रोल ऑफ फॉर. अब क्या होता है कि जो output of PV and battery is controlled by inverter, because as you can see here they are connected through inverters to the AC bus. ठीक है. तो अब PV and battery जो है are modeled by interface to the AC grid using dynamic average model DA models. Okay, is interfaced to the AC grid using dynamic एवरेज मॉडल. ठीक है. और इसमें जो बैटरी कंट्रोल्स होते हैं जो भी पीवी और बैटरी के, दे आर बेस्ड अपॉन द डीकपल्ड पीक्यू कंट्रोल स्ट्रेटजी पे. ये लास्ट टाइम मैंने इसको समझाया भी था. ओके. इसमें जो है इंटरनल स्टार्टअप और प्रोडक्शन लॉजिक ब्लॉक्स होते हैं. ठीक है. So I will show you, I think, yes, this is the control strategy of this. This is PQ control strategy of a battery and a and solar PV. Okay, here this is the reference power. It is given here. Then it is VD. Then all these control strategy is given to PWM based on the generation of the switches. The inverter will control the output of that. Okay. Now here comes the diesel generator. Actually, diesel generator, yes, I have told you about in the grid connected mode. It will help in the voltage regulation by controlling the excitation. Okay. But in the islanded mode, it will support the voltage and also the frequency. Okay, in isochronous mode. Now, what happens here is that now if there is a speed governor. What it will do? It will regulate the speed. It will, I will write it down here. It will regulate the speed, thereby controlling the frequency of the diesel generator. Okay. And how we can control the speed? By changing the mechanical input of the synchronous machine rotor. अब इस तरीके से हम फ्रीक्वेंसी कंट्रोल कर सकते हैं. बट इफ यू वांट टू कंट्रोल द वोल्टेज, वी हैव टू control the excitation system. Now, in controlling the excitation system, it will help in what it will help in regulate the terminal voltage. Okay, by now how we are going to control the excitation? By varying the field current. Okay, as we know, there are three types of excitation. First one is overexcited generator, in which the diesel generator injects reactive power into the system. Then comes another type, which is under excite. What happens here in this? The diesel generator absorbs reactive power from the system or the network. Okay. Then comes the third type of excitation, which is normally excited. Okay. What happens here in this? The power factor is unity. Okay. So this is the uh, working of a diesel generator. So what I have said over here, we are going to implement the modeling of this microgrid. Then we will see the results. Okay, how the results are going to be held. What are the results like? So, so if we move on to the simulation part, we are going to simulate different cases here. In the case one, we will going to see where the no DER connected means such as PV, diesel generator, battery in the system. Then we will analyze second case when there is no DAR in the system, but additional load switching occurs. No DAR, but additional load has been switched on. Additional load from it vary from 0.5 megawatt to 1 megawatt. Then we will analyze another case, which is case 3, in which DER is switched on and battery is in charging mode, and it will charge in the off peak hours. Okay, or diesel generator is in operated in a voltage regulation mode, which is overexcited mode. Okay, voltage regulation. Then we will analyze another case 4, in which DER is on, distributed energy sources is on, battery is set in the discharging mode, battery is in discharging mode, and the diesel generator is in voltage regulation mode. It will be overexcited, and PV insulation is decreasing when it operates at the MPPT. Okay? So these cases we are going to analyze. So and all these cases are in the grid connected mode. This is more important. So I will show you some simulation results. I think yes, these are the simulation results. So this is a grid bus. This is an example of from the RTDS. Then this is a battery. This is load bus. Diesel generator is here. We can set the SOCs of the battery over here. We can set the temperature of PV over here, and we can also set the generating operating conditions over here. If we analyze the PCC voltage in kilowatt, and then this set of shows the PCC voltages. Well, PCC means at the point which is point of common coupling, and it is connected through a breaker, so it will show the variation of the PCC breaker current. Okay, this is for the case one. If we go on towards the case two, in the case two, the load switching is happening at this time. As we have said that we will switch our load from point 1 to 1 megawatt whenever the load switch, the current will gets increased. Okay, like this. Then comes the case 3. This is the simulation results. This is the current of the battery. This is solar PV. This is for generators, and this is the I grid variation of the current in the grid. Then comes the case 4. What is the case 4? In the PV, we can see here like 1. The value over here is 1, and this is value is -1. Okay, for solar PV. If you see on the value here is zero point 0.5, this is minus zero point 0.5. So the current is decreased. So the output will decrease. Why? Because in case 4, we have seen, we have assumed that our PV is insulation is decreasing. So that's why the operating output characteristics of the solar PV will decrease. Then another case here is the islanded mode. In islanded mode, how this all are going? There are actually, I will write 3 cases. We are going to analyze 3 cases. First, let me write it over here. What are the cases we are going to analyze in the islanded? So in islanded mode of operation, okay. Case 1. In islanded mode of operation, main grid will be disconnected. Main grid disconnected. It will be constant for all the cases. Okay. Battery charge हो रही है. Battery is charging. How? From the solar PV. And PV is operating at the MPPT, is at maximum power point. And diesel generator. Now, diesel generator will help in 2 ways. It will help in voltage regulation and the frequency regulation. Okay. Then another case are going to analyze. Main grid is still disconnected because in islanded mode of operation, main grid will always be disconnected. Now, in this case, we are analyzing battery discharging and PV insulation levels are reducing. You will be having question in your mind, why are we analyzing the different sets of cases? Why are we analyzing? Because in the starting of the lecture, I have said that कि हम जब किसी फिजिकल implementation को जाएंगे उससे पहले we are going to test various cases how our system is behaving, because in the real world scenario, if there is something happen like this, we know what corrective action we are going to take. So that's why we are analyzing these type of cases. In this, all the cases in all the cases of case 2 plus additional load switch, same zero point 0.5 to 1 megawatt, we will see how the characteristics of the current, of the solar current, battery current, and all these things will behave. Okay. So now in the case 1, this one shows the variation of the battery in kiloampere for the case 1. You can see the values are -1, the maximum values. This is for the generation, this is for the PV. And grid current value is not here. Now, in this case too, what happens here is that battery is discharging and the PV insulation level are this. So the PV output will get reduced. It reduced to 0.5 maximum value. Now in the case 3, there will be a time when when the load will be switched on. At that time, so at that time, there will be two states. At the time of switching, the transients will come, and after that, the steady state. Both the variation of the current of battery, PV, and generation or diesel generator is being shown over here. Now, another case study has been done in this is standalone DC microgrid. So here in this This is a DC microgrid. Okay, there are PLL phase locked loop. MPPT is here. Voltage of PV and IPV will be going in here. It will give an output. Okay, then there are PI controllers. In this reference DC voltage is given. Okay. Then after that, there are all these reference current will go to the inner controller loop. Then after this, these are given as the input to the converter. Based on that, the control scheme we are going to see. Okay. So here, what we are going to see here, a, a simulation with a DG. Okay. In the figure one, we are here the variation of power generation is shown in the green like this. Okay, this shows the DC bus voltage. Okay, at the DC bus where all these DARs and the load are connected, and C shows the significance of the C show what C shows. C shows the variation of battery SOC. Initially it is 80%, then after they increase it, then after that it gets discharged, then it goes on like this. Okay. Then again in the D, it shows the battery and capacitor powers, and then after that it shows the diesel generator in this F. It shows the output power of the diesel generator. Okay, so here we are actually like let me show you how we are going to see here this. Okay, just a minute. Okay, so now another here is this. This is all about the which I talked about the standalone and DC microgrid. Actually, there are two types. We have done a two case study. Case study one in which standalone DC microgrid is there. Then another case study is in which two interconnected local DC microgrid are there. So I will draw a first one. Okay, I standalone. So what here in the DC microgrid, there is a bus. Okay, now there are PV panels. PV panels are there which give power, and DC systems are given, and it is connected like this. Then come the diesel generator DG. AC to DC conversion will be done to connect it to the DC bus because it is a DC microgrid. The bus here will be DC. Then comes the battery. Then comes the battery. Then it is connected through DC. Why are we connecting through it? Because we can control the voltage or if voltage so that the charging and discharging can be controlled. Now comes another uh, supercapacitor. It is connected through DC to connect to this. So there are then there is a wind, which is another also one type of renewable based source. Wind, as we know, wind generally gives output in AC, so we have to use AC to DC and then again DC to DC to control the output voltage. Then there are several loads are connected. Let's say these are load 1, these are load 2, this is load 3. So this is an structure of a standalone DC microgrid. Basically, it connect. Why are these loads are connected in this so that we can we can simulate the real world loads. Because in the real world there are the different types of load, which are there are critical loads and there are non-critical loads. So based on that we can हम इनको जो है सिमुलेट कर सकते हैं कि क्रिटिकल लोड्स हैं या फिर नॉन क्रिटिकल लोड्स हैं. लेट्स से we assume this is the critical load CL. Let's mark this is the CL. So this is an structure of a DC microgrid. Okay. So based on that, I have talked about the case study. So this is the main control scheme. Based on that, the variation in the DC bus voltage are shown over here after implementing this structure. Then another case is another structure of a microgrid here in the second case study which we have taken up is the interconnected to local DC grid. Okay. So what happens here in this? Let's say this is a DC microgrid first. There is another DC microgrid 2. Okay. So there will be some DERs will be there. Energy storages will be there. Okay. Loads in a in any microgrid will be here. And these two are connected to a bidirectional converters. Bidirectional why? Because energy can flow depending upon the requirement either from left to right or right to left, or we can say from one microgrid to another microgrid. Therefore, another DARs will be here. Load same as in the case of first microgrid. There will be different types of this. Okay. Now, this is, a schematic, or I can say broad view of a two local microgrid connection is here. Okay. But in reality, how they are connected, I will show you. So in reality, how they are connected, this is a DC bus. Okay. इस तरीके से हम जो है रियल टाइम सिमुलेशन करते हैं. क्या करते हैं हम, जो आरटीडीएस मैंने बताया उसके अंदर ये सब ड्रॉ करके उनको एनालाइज करते हैं वेरियस केस स्टडीज. So this is a DC bus of the first microgrid. Then there is a DC bus of second microgrid. Okay. अब इसमें क्या है, लेफ्ट हैंड साइड पे देयर विल बी पीवी पैनल्स और इसको हम कनेक्ट करेंगे डीसी टू डीसी से because we want to control the voltage. Okay, based on that we will decide whether whether it is charging or discharging, all those control things we can. Then storage, it is also connected like this, same which I have shown earlier. Connection architectures are same. Okay, now in storage the power can either go like this or go like this, because when it is get when storage are discharging their energy, the power go from left to right towards the bus. When it is charging, it will go like this. So these are all are bidirectional. So we can say that the power flow is bidirectional. Here only this much, but here in the loads the direction of the power will be like this. Now comes the another microgrid simulation, or we can say how we going to design. PV panels will be here, same storages, it will be connected to the converters. Then we have loads which will be connected like this. I will show the power flow. In this, the PV power flow will be like this. But in storage, the power flow can be like this, but here the power flow will be towards the load. Now come the main part here, how we are going to connect. As I said, we are going to connect it through the bi-directional converters. Okay. So basically, we are going to connect switches, okay, in this. Let's say this is switch 1, this is switch 2, this is switch 3, this is switch 4, okay. It is connected like this. Then another switch will be here. Let's say it is 5. It is connected to S6, then it is S7, then S8. Okay, so it will be connected to them like this. Then these are two connected like this. Okay, there will be a reactance connected to between them. Okay, so this is a bi-directional. These are connected here. This is C1 and there it is C2. Just a second. Okay, so this is how uh, uh, bi-directional uh, converters are connected. This whole system, it is known as ADCMG. What it is? ADCMG, which is autonomous microgrid. Okay, autonomous DC micro grids. ठीक है, this will be known as. ओके, तो इसमें क्या होता है, ईच एडी, इसको क्या कहते हैं, ये क्या है, एक एडीसीएमजी है, दिस इज अनदर एडीसीएमजी. ओके, हर एडीसीएमजी यानी ऑटोनोमस डीसी माइक्रोग्रिड में एक वोल्टेज सोर्स है, एक बैटरी है, एंड देयर आर ग्रुप ऑफ सोर्सेज फ्रॉम द रिन्यूएबल एंड स्टोरेज डिवाइस. पीवी सोर्स को हमने कहा यहाँ किससे इंटरफेस करा है, पीवी सोर्स को हमने इंटरफेस करा है इससे, थ्रू द बूस्ट कन्वर्टर. दिस इज boost converters, and bidirectional buck boost DC converters are utilized for connecting the battery storage. Why bidirectional? Because मैंने बताया कि पावर जो इसके अंदर bidirectional आ भी सकती है for charging and goes away for the discharging. Then another here is that okay, so from here this is how that two DC microgrids are connected. Okay, so now I will show you a results of here how we are going to. अब इसमें कंट्रोल स्ट्रेटजी क्या है बिटवीन टू दिस, कम्युनिकेशन इंडिपेंडेंट कंट्रोल है. इससे क्या होता है, सिस्टम्स रिलायबिलिटी इंक्रीज यूआरजी एंड एफिशिएंट यूटिलाइजेशन ऑफ रिसोर्सेज बढ़ जाता है. इट कवर्स द ओवर एंड अंडर लोडिंग ऑफ एडीसीएमजी एंड इट इंक्लूड्स ओवर चार्जिंग एंड अंडर डिस्चार्जिंग ऑफ स्टोरेज. लाइक व्हाट, जैसे कि मान लीजिए फॉर एग्जांपल कि फॉर सम एरिया, फॉर लेट्स से कि फर्स्ट जो है डीसी माइक्रोग्रिड, इट हैज अ हायर रिक्वायरमेंट, बट हियर द पीवी इज नॉट जनरेटिंग एज मच पावर, so the demands cannot be met. So what happens here is, though, if there the second microgrid is possible, can supply the power towards the first microgrid. So what it will do, it will increase the reliability of the first microgrid. Okay, and also it will covers the underloading. If for example second microgrid is overly loaded, so DC first microgrid can supply power to the second microgrid and makes it under the load. Okay, so this is how the loading can be reduced on any microgrid, and also the reliability and efficient utilization of the resources can be done. ओके। और इसमें क्या होता है कि अगर मान लीजिए फॉर एग्जांपल कि रात में जो है द लोड डिमांड इज नॉट सो मच, तो इट विल हेल्प इन द चार्जिंग ऑफ दीज स्टोरेजेस आल्सो। ठीक है, तो ये एक तरीके का ये बताया गया है इसके अंदर। रीजन वन इज फॉर एडीसीएनजी टू एडीसीएनजी टू, एंड रीजन टू क्या बताता है कि टू से वन में पावर फ्लो हो रही है। ठीक है, विद इन द डीसी माइक्रोवेव। ओके, तो इसका फायदा क्या होता है? एडीसीएमजी कंट्रोल का इफेक्टिव मैनेजमेंट ऑफ द स्टोरेजेस एंड सोर्सेज बेस्ड ऑन द बस सिग्नलिंग मेथड. It also distributed the control, and it also eliminates the communication between and embraces the extreme scenario of individual grid, which is very important. मान लीजिए किसी भी डीसी ग्रिड पे कोई एक्सट्रीम आउटेज सिनारियो क्रिएट हो जाता है जिससे पावर रिड्यूस हो जाती है, फ्लक्चुएशन हो जाता है, तो सेकंड जो है second grid can help out that thing also. The first microgrid also, and bus voltage and deviations are under the loops. Okay, now we will talk about the now we will talk about another thing here, which is control strategy of the voltages, which is very much important. I will give you a brief idea. I hope you have you know learned it about in detail in the lectures. Here I'm just giving you a smaller and a brief idea regarding that. Okay, just a second. Now, okay. So we know that whenever there is in any in any microgrid, we have to control the voltage, because voltage is very important part. So there are various voltage regulating devices, various voltage regulating devices like on-load tap changer OLTC, D-STATCOM, okay, and converters and renewable converters of RES. Okay, क्या होता है कि renewable energy sources भी helps in improving the voltage regulation, like solar or wind. They are also they what happens there is there कि जब वोल्टेज का फ्लक्चुएशन ज्यादा हो जाता है तो आरईएस रिन्यूएबल एनर्जी सोर्सेज का इस्तेमाल करते हैं फॉर रिड्यूसिंग द फ्लक्चुएशन ऑफ द वोल्टेज। तो इसमें एक आता है, एक स्कीम है कोऑर्डिनेटेड कंट्रोल वोल्टेज, विच इज नोन एज सीवीसी, कोऑर्डिनेटेड कोऑर्डिनेटेड वोल्टेज कंट्रोल। अब इसका ऑब्जेक्टिव क्या है? What is the main objective of this coordinated voltage control scheme is, first, optimally, I will write it down here, optimally utilize different compensating devices to increase reactive power reserve. Okay, and also helps in reduction in post voltage, sorry, post fault voltage recovery time. Okay. So coordinated voltage control scheme का objectives क्या है? First objective is to utilize the different compensating devices like OLTC, DS, STATCOM or converters of REC so that the reactive power reserve can be increased because the reactive power is directly responsible for the voltage regulation. Another objective of the CVC is to regulate the voltage recovery time. Like say, if there is any fault occurs, and after that fault occur, it has to clear that fault. Then the voltage should come up toward the nominal value. So that time which it takes to that recovery, it should be reduced. Based on the communication based I will write it down here based on the communication there are two types of CVC. What are they? One is centralized, which is with communication. Okay. Then another one is decentralized, which is without communication. Okay. So depending upon the communication, CVC means coordinated voltage control scheme. There are two types of CVC. One is centralized scheme which have a communication from other devices and a decentralized which don't have any communication. Now, what are the devices which I talked about? Voltage regulating devices. Okay. There are various types of voltage regulating devices. First one is OLTC. Okay. OLTC. ठीक है. What it does, it changes the position of tap if the voltages of buses vary within plus minus 10% of its nominal value. Nominal value. तो ये क्या करेगा 0.9 से 1.1 PU के बीच में. ओके. तो कैसे ये चेंज करेगा? If the voltage variation at any regulated bus where the OLTC has been installed, if it crosses the predefined dead band, then what happen here? The OLTC will change its position. So for each step variation of OLTC, it constitutes a 0.000625 per unit change in the voltage. Okay, I will write it down here. OLTC changes its tap position when it crosses the predefined deadband. So, step variation of an OLTC generally corresponds to 0.00625 per unit change in voltage. Okay. अब आता है एक अनोदर डिवाइस विच इज DFIG, okay, and D statcom, okay. This also helps in the regulation of voltages. I will show you a diagram actually. It will help in understanding if it possible. Let us see. Actually, one more important point here is that OLTC, D statcom, all converters are operate in a, this is very much important point, operate in a decentralized manner, okay, without any communication, without any communication among themselves to regulate the voltages of their respective connected buses, okay. Now, okay, another thing is here, what is the variation of what is the limitation of the, because for every scheme there are some limitations, okay. Limitation of CVC scheme, what is this? First, it gives importance to the speed of the operation of devices only, and do not check for availability of the device for particular operating conditions, okay. And it is like I will write it here, speed of operation of devices only. Another thing is here is that all the fast acting devices are considered for injecting power simultaneously. Okay. CVC scheme में क्या होता है, ये माना जाता है, it has been assumed that fast acting devices will be used for injecting the power, but it has several advantages, like it utilizes the all devices effectively so that the reactive power reserve gets increased. It improves the voltage profile को increase करता है. It also improves the capability, fault right capability of the devices. It also improves the fault right throw capability of a device, ठीक है. और transient conditions of the, of the system is also improved, ठीक. अब इसमें क्या होता है कि स्टेजेस क्या है, स्टेजेस ऑफ सीवीसी स्कीम, ठीक. पहला स्टेज क्या है, आइडेंटिफाई द ऑपरेटिंग कंडीशन, आइडेंटिफाई द ऑपरेटिंग कंडीशन ऑफ द ग्रिड, ठीक. अब क्या ये कैसे आइडेंटिफाई करेगा, इट इज आइडेंटिफाइड, आई विल राइट इट डाउन हियर, आइडेंटिफाइड बेस्ड ऑन द रियल टाइम voltage information from the voltage regulating device, voltage regulating buses, ठीक है. फिर उसके बाद क्या करता है, इट सेकेंड में क्या करेगा ये, इट चेक द अवेलेबिलिटी ऑफ द डिवाइसेस टू असाइन अ मास्टर एंड अ स्लेव रोल, ठीक है. तो सेकेंड स्टेज क्या होगी, it checks the availability of different devices and to assign the master slave role, okay, ठीक है. अब इसके अंदर क्या होता है, OLTC एंड DCMG क्या होते हैं, दे आर जनरली यूज फॉर स्टेडी स्टेट एंड डायनामिक स्टेट, ठीक है. ये डिवाइसेस डायनामिक स्टेट या स्टेडी स्टेट में यूज करे जाते हैं, लेकिन विंड, जीएससी एंड डी स्टेटकॉम, इन डिवाइसेस ये क्या होते हैं, दे आर अवेलेबल फॉर ऑल स्टेट्स, आइदर ट्रांजिएंट, डायनामिक्स और ओके। देन आफ्टर दैट व्हाट इट डज हियर, फिर उसके बाद आता है थर्ड स्टेज इन द सीवीसी स्कीम। Then it introduces the delay of time in the operation. अब इसका ये क्यों कराया जाता है, क्योंकि क्या होते हैं, डिफरेंट टाइप्स ऑफ डिवाइसेस होते हैं, इनकी स्पीड ऑफ ऑपरेशन दे आर डिफरेंट, लाइक विंड, जीएससी, डीसीएमजी, दे आर फास्ट एक्टिंग डिवाइसेस, और ओएलटीसी क्या है, इट इज अ स्लो एक्टिंग डिवाइसेस। तो डिले इज introduced to ensure slow acting devices can complete their actions. Okay, then what happened? Then fast acting devices are allowed to operate. ओके okay. अब इस वैल्यू को कैसे कैलकुलेट करते हैं, क्या होता है कि ओके, अब क्या है इसके अंदर, वन ऑफ द मेजर थिंग हियर इज दैट इफ द वेटिंग टाइम पीरियड is less than the delay time, तो OLTC might not complete its action. ठीक है, तो वेटिंग टाइम है फॉर फास्ट एक्टिंग डिवाइसेस, इट शुड नॉट बी less than the delay time, otherwise OLTC will not complete its action. So how this delay time is calculated? Delay time calculation is TD is equal to TD is equal to 1 minus V bus per unit, okay, multiplied by time of OLTC divided by voltage of OLTC. What is VOLTC? V bus क्या है? V bus है, it is the per unit voltage measured at bus, let's say Y, any bus at which the corrective action is going on. Then TOLTC, what it is? It is the time which is required by OLTC to change one tap. Okay, ये है TOLTC. Then VOLTC क्या है? It is the per unit change in, it is the per unit change in voltage due to single tap change of OLTC. एक टैप में चेंज पे जितना पर यूनिट चेंज ऑफ वोल्टेज आता है, जिसको हम कहेंगे वी वोल्टेज। इस तरीके से हम व्हाट आर वी गोइंग टू डू, वी आर गोइंग टू कैलकुलेट द टाइम डिले। ठीक, so these are the various steps which are we going to see. Now, another thing here which I want to discuss with you is okay. So, now we are going to discuss how the renewable energy is connected, energy sources are connected to the microgrid. ओके, तो किस तरीके से क्या होता है कि रिन्यूएबल एनर्जी एप्लीकेशन में जनरली इन्वर्टर्स आर कनेक्टेड in parallel. Why? To increase the generational capacity. Okay? और इसीलिए जो पीवी एंड विंड प्लांट जो इन्वर्टर्स कनेक्टेड होते हैं दे आर पैरेलल ऑपरेटेड इन्वर्टर्स. ओके. और इन ग्रिड कनेक्टेड मोड. ठीक है. अब जब एक पैरेलल का ऑपरेशन होता है तो लेट्स से देयर इज inverter 1 over here. Let's say there is another inverter, two inverters are connected, and both these inverters have identical parameters. ठीक है. Now they are connected to the like this. This is grid inductance. This is VG. Okay. So here in this there are two types of current. One is a common current, which is I will show here, and it is a common current. Another type of current also flows, which is interactive current. Interactive current. Okay, and it flows, it is actually equal in magnitude, and it flows between these two inverters, but they are out of phase each other. ठीक है, दोनों एक दूसरे से क्या होते हैं, आउट ऑफ फेज होते हैं. कॉमन करंट क्या होता है, वो करंट होता है जो ग्रिड में फ्लो करता है. ठीक है, इंटरेक्टिव करंट इस तरीके से फ्लो करेगा. ठीक है. तो अब इस इंटरेक्टिव करंट को ओवरकम करने के लिए क्या करते हैं, फॉर इन्वर्टर it is required the behavior. uh, so what are we going to do here? The problem I will explain in short because I have to solve the question. The problem of interactive current is does not occur in L filtered inverters due to first order nature of the system. ठीक है, एल फिल्टर इन्वर्टर्स यूज करे जाते हैं जिसकी वजह से जो है ये जो प्रॉब्लम ऑफ इंटरेक्टिव करंट जो है जनरली ओवरकम हो जाती है. इसके तुमने ये एक डेरिवेशंस भी देखा होगा, हाउ आर वी आर गोइंग टू किस तरीके से डेरिवेशन करते हैं वो you would have learned that in the lectures, because right now time is not very much, so I would not go into detail of the derivation of that interactive current and how we can overcome. So we will now solve the questions actually. because it will help in understanding. So here, what you have to do here, I will write the question and you have to write the answer in the chat box. Okay? Or the question number first, identify the correct statement. Okay? First A. An under excited synchronous generator injects reactive power into the system. Then B. An overexcited generator injects reactive power into the system. Then C. Normally excited synchronous generator operates at unity power factor. Then D. An under excited synchronous generator operates at unity power factor. So options, just a second. This is first, this is first, this is second, this is third, this is fourth. So the correct options are A 1 and 2, B 2 and 3, C 3 and 1, and D none of the above. So write the answer. The question here is that we have to identify the correct statement. An underexcited synchronous generator injects reactive power into the system. An overexcited generator injects reactive power into the system. An normally excited synchronous generator operates at UPF and an underexcited operates at UPF. So we have to write the answer. Okay. So if we go through the options, we can see that the second option is the correct one. Third is also the correct. Rest are wrong. So basically, second option is the second and third is the correct one. Yes, yes. Second and third is the correct one. Question number two. Transformation converts ABC to DQ reference frame. So options are A. Clark, B. Inverse Spark, C. Inverse Clark, D. Spark. You have to write the correct answer. Okay, so here the question says which of the transformation converts ABC to DQ? So here the correct is spark. The answer is very simple. It is spark. Now question number 3. Identify the correct statement. Okay. First one is the battery and supercapacitors are connected to an isolated DC microgrid through a unidirectional buck boost converter. ठीक? The battery is connected to isolated DC microgrid through a bidirectional bidirectional converter, not a supercapacitor. C. The battery and supercapacitors are connected to an isolated DC microgrid through a bidirectional buck boost converter. D. D is supercapacitor is connected to DC microgrid through unidirectional converter, while battery connected through bidirectional, which is the correct answer. So write in the chat box. Okay, C. People are saying C. देखो क्या है इसके अंदर कि बैटरी और सुपर कैपेसिटर्स कनेक्टेड होते हैं डीसी माइक्रोग्रिड के। पहला ऑप्शन क्या कह रहा है? इट इज कनेक्टेड थ्रू अ यूनी डायरेक्शनल बक बूस्ट कन्वर्टर। नहीं, ऐसा नहीं होता। व्हाई? बिकॉज आई हैव जस्ट टोल्ड यू अबाउट in battery, whenever it is connected to any bus, it is a bi-directional power flow. Sometimes it gets discharged and sometimes it gets charged based upon the condition or the reference command. So it must be connected to the bidirectional. Same goes for the capacitor. For charging the capacitor, the power must come into, and for discharging, the power must go out. So these both are connected through a bidirectional. So basically, the correct answer will be C. The battery and the superconnector are connected to an isolated DC microgrid through a bidirectional buck boost converter. C is the correct answer. Okay, so we will solve one more question. Question 4. Which of the following is true for underexcited synchronous generator? Okay, okay. Now ये तो हमने पहले solve इस तरीके का कर ही रखा. There is no need to. I will write it in the grid, microgrid. Steady state operating condition. The range of voltage magnitude is considered acceptable. कौन सी रेंज एक्सेप्टेबल हो? तो ए है 0.88 to 1.01 per unit, B 0.95 to 1.1 per unit, C 0.9 to 1.1 per unit, D 0.9 to 1.05 per unit. Just a second. This is 1.2. This is 1.2. This is 0.8. Okay. So which of these range in a steady state operating condition the voltage magnitude is acceptable, or we can say in allowable limit? Yes, just told you about this. This is the operating condition which says plus minus 10%. Another question. What is the per unit change in voltage for a step of OLTC? A 0.0062, B 0.062, C 0.00062, D 0.62. I have just told you about this. For the per unit, each is 0.0062. Okay. So another question, question 6. What happens to interactive and common current in a parallel inverter system when resonance occurs? They stabilize due to filtering. Okay. B. They increase, causing instability. They decrease, improving system reliability. D. None of the above. क्या होता है कि जब इंटरएक्टिव ऑफ कॉमन करंट्स होते हैं पैरेलल इन्वर्टर सिस्टम में, तो वो जब रेजोनेंस अकर होता है, तो व्हाट दे डू, दे इंक्रीज and cause the instability in the system. So the B option is the correct one. Question number 6. Which of the following yes, Ravinder, are you able to hear me or not? Hello? Yes, yes, you can speak. How I should be. Am I audible or not? Okay, okay, okay. So Ravinder, what you want? I don't think so. What he's trying to say. If you have any concern, you can write in chat box because I am not able to hear you if you are speaking. Okay, let's move on with this. Which of the following statements are correct? regarding interactive current. पहला, they are they flow between parallel inverters. B, they are out of phase. C, they are equal in magnitude. They are also flown towards the grid. So this is first, this is second, this is third, this is fourth. So write the correct answer. A, first and fourth. B, first, second and fourth. C, third, first and fourth. D, second, first and third. So write in the chat box. So basically, I told you about कि ये जो इंटरेक्टिव करंट होते हैं, इंटरेक्टिव करंट क्या होते हैं? दो तरह के करंट होते हैं, एक तो इंटरेक्टिव और एक होता है कॉमन। ठीक है, तो इंटरेक्ट कॉमन करंट क्या करता है? इट फ्लोज टुवर्ड द ग्रिड। ओके, इंटरेक्टिव करंट क्या होता है? इट फ्लोज बिटवीन द पैरेलल इन्वर्टर्स। जो भी इन्वर्टर्स हमारे लगे हुए हैं उनके बीच में फ्लो करता है। ठीक, तो पहला ऑप्शन सही। और ये आउट ऑफ फेज होता है एक दूसरे के। दे आर इक्वल इन मैग्नीट्यूड। फर्स्ट टू, वन टू थ्री आर करेक्ट। जो दे आर ऑल्सो फ्लोन टूवर्ड द ग्रिड, इट इज रॉन्ग बिकॉज कॉमन करंट फ्लो करता है ग्रिड की तरफ। तो फॉर दैट आई वुड से द करेक्ट ऑप्शन इज डी। क्वेश्चन नंबर 7, which of the following is false regarding the harmonic effect in power system? पहला, harmonics are caused by non-linear loads. Okay, they reduce overall efficiency. C, harmonic current cannot interfere with telecommunication lines. D, all. So give me the correct answer. सी। ओके, ठीक। तो करेक्ट आंसर क्या है कि हार्मोनिक इफेक्ट ऑफ कोर्स नॉन लीनियर लोड से होते हैं, ओवरऑल एफिशिएंसी डिक्रीज कर देते हैं, इट दे इंटरफेयर विद द टेलीकम्युनिकेशन लाइन। द करेक्ट ऑप्शन फॉर द फॉल्स स्टेटमेंट इज सी। ओके, so question number 8. An OLTC is connected between nodes 1 and 2, ठीक है, regulating the voltage at node 2 with respect to node 1. The voltage at node 1 is 1 pu and the tap position of OLTC is -10. So we have to compute the voltage at node 2. ऑप्शंस क्या हैं? एक ऑप्शन है 1.625, बी है -0.0625, सी है +0.0625 एंड डी है 0.9375। तो इसका क्या निकालना है आपको? OLTC की टैप पोजीशन दी हुई है, so we have to calculate the voltage at node 2 और OLTC लगा कहाँ है? It is between 1 and 2, so we have to calculate this. So write in the chat box, give you a minute. So basically क्या है इसके अंदर, मैंने अभी बताया था थोड़ी देर पहले, फॉर each step of OLTC the change in voltage in per unit कितना आता है? 0.00625, ठीक है, हर एक स्टेप के लिए। तो यहाँ पे वोल्टेज ऑफ नोड 1 कितना दिया हुआ है? 1 पर यूनिट। नंबर ऑफ, और एक्चुअली टैप पोजीशन कितनी दी गई है? इट इज -10। ओके, सो टैप पोजीशन ऑफ OLTC इज कितनी? -10, ठीक है। हर ईच टैप और वी कैन से स्टेप ऑफ OLTC कितना वोल्टेज चेंज बताता है? 0.00625 फॉर 10 स्टेप और वी कैन से स्टेप कितना बताएगा? 0.0625, but this is minus, so we will put minus. फॉर -10। ओके, यहाँ -10 पे लगा हुआ है, ठीक है। तो अब वोल्टेज ऑफ नोड 2 कितना होगा? 1 माइनस 0.0625। If we calculate it, let me calculate it by using a calculator. 1 minus 0.0625, it will come out to be 0.9375 per unit. इससे हम पता कर सकते हैं इस से कि जो वोल्टेज एट नोड 2 कितना होगा? 0.9375. So if we go towards the option, we can see this one is the correct. All these are wrong. I hope you have understood this. Okay. Question number 9. An OLTC is, sorry, what is not true in the case of isolated mode of operation in AC microgrid? Okay. A. Grid is not available. B. PV will always operate in MPPT condition. ठीक. C. Battery will charge and discharge on the reference command. D. None of the above. ओके, तो इसमें आपको ये बताना है कि which of the following is not true regarding the isolated mode of operation in the AC micro. Isolated में मतलब क्या हुआ? Grid is not there. So basically पहला ऑप्शन तो गलत ही हो गया. It is not available. तो ये तो सही है. थर्ड, सेकंड क्या? PV will always operate in MPPT mode. No, it is wrong. PV may or may not operate in a MPPT mode. Battery will discharge and discharge on the reference command. Yes, it is dependent on the reference command whether it has to charge or not. So from here we can say that B is the correct answer to this question. I think, okay. Okay, one more question. Question number 10. Select the correct statement regarding multi-parallel inverters. A. Common and interactive currents will be unstable if the poles of their characteristic equation lies in the right half of plane. Okay, S plane actually. Second है the interactive currents flow into grid. C है problem of resonance occur in L filtered inverters due to first order nature. ठीक है, तो ये बताना डी नन ऑफ द अबव. ठीक, व्हाट इज डी? डी नन ऑफ द अबव. ठीक. हाँ, देखो सही. करेक्ट आंसर इज ए. यस. देखो क्या है, कॉमन एंड नॉन इंडक्टिव करंट विल बी अनस्टेबल इफ द पोल्स ऑफ द कैरेक्टरिस्टिक इक्वेशन लाई इन द राइट हाफ प्लेन. इट इज करेक्ट. ओके, ठीक है. बी ऑप्शन क्या है? द इंटरएक्टिव करंट फ्लोज इनटू द ग्रिड. रॉन्ग. प्रॉब्लम ऑफ रेजोनेंस अकर इन एल फिल्टर इन्वर्टर ड्यू टू फर्स्ट ऑर्डर नेचर. नहीं, फर्स्ट ऑर्डर नेचर की वजह से रेजोनेंस की प्रॉब्लम रिमूव हो जाती है, तो ये गलत है. वो तो है, तो इसीलिए आंसर ए is the correct answer as per this question. So this is all today from my side. I hope you have got the basic understanding and you have revised all those things which you have learned in your lectures. Okay. So if you have any question regarding this, you can ask me. Otherwise, you are free to go. Thank you. Mhm. Okay. Thank you.